In this video, let's solve a problem on error analysis. We have the diameter of a wire as measured by screw gauge was found to be 2.620, 2.625, 2.630, 2.628 and 2.626 centimeter. All are in centimeter. Calculate A. The mean value of diameter. B. Absolute error in each measurement. C. Mean absolute error. D. Fractional error. E. Percentage error. F. Express the results in terms of percentage error. Now, this kind of question is describing random error. We say in random error, the causes of error is not known to us. And here, to correct the error, you have to perform the experiment a large number of times and take the arithmetic mean of the observation. The mean value will be very close to the most accurate reading. Thus, the mean value here will be the arithmetic mean of all these observations. Now, for observation 1, let's call it A1. So A1 is 2.620, comma, A2 2.625, A3 2.630, A4 2.628 and A5 2.626. So let's say these are the observations. Now, to find the mean value of all this diameter, they are all in centimeter. So we need to take the arithmetic mean of all this observation, and that will be our true value. So now, A mean, that is AM. So let's take it as our arithmetic mean. So it's equals to sum of all the observation A1 plus A2 plus A3 plus A4 plus A5 divided by 5. So therefore AM, that is the true value or mean value of diameter. So add everything, that will be 2.620 plus 2.625 plus 2.630 plus 2.628 plus 2.626 divided by 5. So mean value is equals to, so add everything together and press your calculator. That will be 2.620 plus 2.625 plus 2.630 plus 2.628 plus 2.226 at 2.626. 2.626. So everything is 13.129 divided by 5. So 13.129 divided by 5. That is 2.626. So that is the answer. So that is the mean value of diameter. So we have solved the first one. So now let's see the second one. Absolute error in each measurement. So you can jot this. So let's clean the canvas. Absolute error in each measurement. So we have discussed the absolute error. So we say absolute error is the difference between the true value and the measured value of a quantity. So here our true value is am. We'll take our mean value as the true value since it will be very close to the real value. So now am is our true value and is equals to 6.626. That's our last result in A. Our final answer in A, 2.626. So is our true value 2.626. So that's our last result in A. So now let's use it to find the absolute error in each measurement. So now to take the absolute error, we have said is the difference between the true value and the measured value. Here we have our A1. So this will be our A1. A1, A2, second measured value, A3, A4, A5. So just 5 values. So now take the difference. So in this case, the A1 is equals to AM minus A1 delta A2 is equals to AM minus A2 delta A3 is equals to AM minus A3 delta A4 is equals to AM minus A4 delta A5 is equals to AM minus A5. So we have already said that the absolute error is the difference between the true value and the measured value. Now we take AM as our true value. So for the first measured value, absolute error is the the original value, which is the true value, the mean value that we take as our true value now, minus the measure value, that is A1. For the second measure value, it's still the mean minus the second measure value. So that's what we'll do for all. So now we can say delta A1 now is 2.626 minus A1 2.620. So this is our A1, A2, so use it throughout. So now delta A2 That is absolute error in second measurement. 2.626 minus the second one, 2.625, delta A3. So the third measurement, error in the third measurement, 2.626 minus 2.630. So this is the third one. Again, delta A4. So absolute error in the fourth measurement, 2.626 minus 2.628. Then delta A4, 2.626 minus 2.626. So now that is our mean absolute error. So now the absolute error, let's press calculator for all this value. So let's clear this place. That means absolute error in each measurement. So for measurements, for the first measurement now, the absolute error, press your calculator. So that is plus 0.006 centimeter. Absolute error in the second measurement, plus 0.001 0.001 centimeter. So this minus this. For delta 2, this minus this, press calculator. Now absolute error in the third measurement, that is minus 0.004 centimeter. Absolute error in the fourth measurement, minus 0.002 centimeter. Absolute error in the fifth measurement, 0.000 centimeter. So we are true. So that is the absolute error in each measurement. So that is the absolute error in the first measurement, second measurement, third measurement, fourth measurement, and fifth measurement. So that's it. So now the C part, mean absolute error. So we define mean absolute error as arithmetic mean of the magnitude of absolute error in all the measurements. So that is mean absolute error. So we are going to take the arithmetic mean of this. So the absolute arithmetic mean of delta A1, delta A2 up to delta A5. See, mean absolute error. So mean absolute error is what we represent as the A mean, which is equals to delta A1 plus magnitude of delta A2 plus magnitude of delta A3 plus magnitude of delta A4 plus magnitude of delta A5. Everything divided by 5. So in this case, we know all our values of delta A1, delta A2, delta A3, delta A4, delta A5. So we'll add everything and take the magnitude, meaning the negative will change to positive. So the mean absolute error now will be equals to 0.006. You can check the final result again for delta A1 and all the negative. By the time we take the modulus of something like 0.004 like this, it will change to plus. That means all our answer will be plus by taking this modulo. So it will be plus. Take note. Now this will be plus delta A2, that is 0.001, plus delta A3 0.004. Take note that delta A3 is minus 0.004, but because we take the magnitude here, this straight line, so this straight line we change it to positive. Take note, that is modulo. So plus delta A4 is also negative, but if we take the magnitude or the modulo, it will still be 0.002. That will be plus divided to remain 1 plus 0.000. Check our last result, everything over 5. So the A mean is equals to, now add everything in your calculator. We have 0.006 plus 0.001 plus 0.004 plus 0.002 plus 0.000. So if you add everything, so you get 0.013 divided by 5. So the mean absolute error is now 0.013 divided by 5. So that is 0.0026 centimeter. So that is our mean absolute error. Now the D part, fractional error. So we define fractional error. You define it as, we check our previous video, we say fractional error or relative error. So it's either you say fractional error or relative error is the same. So now we say the ratio of mean absolute error to the mean value of the quantity measured. So now that is our fractional error. So ratio, let's clear this, the D parts now. D fractional error is equals to ratio of mean absolute error divided by mean value. No, our mean value is AM. Can check again. So fractional error now. Fractional error, ratio of the mean absolute error. So check our last results on mean absolute error. What did we get? So check the last result. Our mean absolute error is 0.003. So our mean absolute error 0 point, that is fractional error. So put plus or minus here, plus or minus. So that means this will be plus or minus the final result 0.003 divided by the mean value 2.626. You can check. So the fractional error now is, you can press your calculator. So that will be plus or minus 0.001. So let me confirm that again. So 0.003 divided by 2.626. So that will be 0.001 plus or minus 0.001. So that is our fractional error. Now, what of percentage error? E. Percentage error. Percentage error is your is your fractional error times 100. So our fractional error is mean absolute error divided by mean value times 100. So and our result here is 0.001 times 100. So if you press your calculator, that will give us plus or minus 0.1%. So that is percentage error. By if you multiply your fractional error by 100, you get percentage error. Now the F part. Express the results in terms of percentage error. So now the results, meaning the final result, F. So express the final results in terms of percentage error. So F. So to express in terms of percentage error, so that means the diameter will be equals to our true value, that is our mean value, plus or minus our percentage error, that will be 0.1%. So that is, we want to express each result in terms of percentage, and we want to express the results in terms of percentage error. Then to express that in percentage error, the diameter, you use the true diameter, which is the mean value. The mean value is our AM, plus or minus 0.1%. Now what is our mean value? That is 2.626 plus or minus 0.1%. Now that is the final answer. So you can split this further by saying 2.626 plus 0.1% or 6.626 minus 0.1%. So we have solved the question. So thank you. In next video we'll do combination of errors. So thanks for watching.